Welcome back to another video, and in this video we'll be dealing with the topic of rationalizing a denominator. Now if you've heard about this before, then that's good, but I believe that this was probably the first time when I saw this in my year 12 textbook. So yeah, without wasting any more time, let's first understand what does it mean by rationalizing a denominator. So as the name suggests, we're basically making an effort to rearrange the denominator in such a way that we're left with no irrational or any such term which is most unlikely to be encountered. Okay, I mean, you get the point, right? So yeah, in simple words, we're basically trying to eliminate any kind of irrational terms from our denominator, just so that it becomes easier to calculate. And yeah, so here I have an example for you. Here you can see that we have 1 over root 3. Now again, root 3 is something that we're not looking for. So to rationalize this, what we do is we'll take this 1 over root 3 and we look at the denominator. We'll just multiply that same denominator with the numerator and the denominator as well. Okay, then we go ahead, we solve it, so we get root 3 in the numerator, and here we get 3. Now you may feel like and be like, oh, we can simplify this further and we'll get 1 over root 3, right? That means you just end up at the same place from where you started. So if you realize that what we just did here was that instead of keeping this in its simplest form, I was like, let me just add a common factor. Usually we just go ahead and we cancel a common factor, right? In this case, I'm going to multiply a common factor so that my denominator is then a rational number. For example for you, now the last example, we only had one irrational term in our denominator. But what if we in our denominator have a rational term but also an irrational term, and you have something like this going on? So now I want you to focus a bit more on these kind of questions. So first I'm just going to start by rewriting the same thing. I just love doing it. Now what I'll do is, again, I'm going to multiply something to both the numerator and the denominator, and it will be the denominator, of course, but what I'll do is that I'm just going to write the denominator, but I'm going to change its sign, and that is what I'll multiply. Okay, so in my denominator I had a positive sign over here, like I had a plus sign, but then I'm going to replace that with a minus sign. Okay, I'm just going to use subtraction at this point, and again we'll just go ahead and multiply. So we get, in the numerator we have 3 minus root 2, and in the bottom you have 3 plus root 2 times 3 minus root 2. Again, we can simplify that. So here I'll get 9 minus 3 root 2 plus 3 root 2 minus 2, right? I just expanded the brackets, and if you can notice, we basically cancelled out the irrational things. So what we're left with is 9 minus 2, which is going to be 7, and that is a rational number. So what we're left with is basically a rational number, right? It's the same thing. We haven't changed it much, but in some way or the other it's still the same thing. But again, all that we did was that we just changed the denominator to something which is rational. So in the third example that I have for you, now I've picked this example specifically because in this example we also have the numerator in irrational form. But am I gonna bother about it? Nope, because we are only focusing on rationalizing the denominator. So again, just like the previous example, I will start by rewriting the whole thing because I just enjoy this so much. And now again, we're going to use the same thing. We'll only focus on the denominator, and because again I have a plus sign over here, that means when I multiply this denominator right here, I'm just going to replace that sign, right? And I'll multiply that same thing to both the numerator and the denominator. Okay, now if I just go ahead and simplify, just write them down. Yeah, so this is what I'm left with. Now again, when you simplify the bracket in the denominator, what you'll realize is that you'll again get rid of the square roots somehow. So when you basically try simplifying it, so I'll just take a moment and I'll simplify it. A moment because I was just not sure if I could do this right on camera. So as you can see, what I'm left with over here is that, again, this is what I've written, this is some of my rough work, and in the above part I understand that we still do have a third, and that's absolutely fine because we just cared about solving the denominator in a way that it becomes rational. So if you look at these calculations, I just expanded these brackets right here into these, and what I realized was that I could cancel out root 21, and yeah, then I had a -4 right here, which then I again solved, and you guys can tell me in the comments if this is correct. And yeah, this is my final answer. This is what I was left with. So I've taken an example in which first we'll have to solve the denominator just to get one irrational thing that we have to later rationalize. So yeah, this time I'll not rewrite the whole thing and we'll just jump straight into solving it. So 5 times 3 here will give us 15. Then 5 times minus root 2 will give me -5 root 2. Then root 2 times 3 will give me plus 3 root 2. And again, root 2 times minus root 2 will give me -2. You can go ahead, solve this again. So 1 over, I'll take this and this. So I get 13. And one thing to remember is that because I have the same third, yeah, we have these two numbers, they have the same third, it's just that the integer part is different. So we'll just keep the same third right here and we'll just solve the integer. So -5 plus 3 is -2, so we have -2 root 2. Now this is something that we're more familiar with and we can rationalize this. So yeah, what I'm gonna do is that I will write this thing again, this, which is 1 over 13 minus 2 root 2 times 13 plus 2 root 2 over 13 plus 2 root 2. If I solve this further, in the numerator I'll have 13 plus 2 root 2, whereas in the denominator I can go ahead and solve these brackets. So 13 times 13 will give me 169. Then 13 times positive plus 2 root 2, that will give me plus 26 root 2. Then minus 2 root 2 times 13 will give me minus 26 root 2. And minus 2 root 2 times positive 2 root 2 will give me -8. So if I go ahead and simplify that, I get 13 plus 2 root 2 in the numerator, and in the denominator I can cancel this irrational part, so I'm left with 169 minus 8, which is 161. So yeah, that was basically how we could get this thing to be fully rationalized and become this over here. Now if you have read the textbook, this is an exam practice kind of question, and you need to rationalize this to get something in the form of p plus q root 5, where you'll be asked to find the values for p and q. Now this is once again really simple. I've seen several of these questions in the exams, so we'll just start by rewriting the whole thing, and I'll just do my regular thing of rationalizing the I actually copied the sign wrong. Yeah, so here I'll make it positive, and again root 5 plus 1. I'll solve the top bracket, which is 3 times root 5 gives me 3 root 5. 3 times plus 1, that is plus 3, minus 2 root 5 times root 5, that will become minus 10, right? Because root 5 times root 5 is 5, and minus 2 into 5 gives me minus 10. And then I have minus 2 root 5 times 1, which is minus 2 root 5. In the denominator, I'll just put these brackets. I don't know why, that just kind of makes things simpler. Again, root 5 times root 5 is going to give me 5. Root 5 times 1 will give me plus root 5. Now minus 1 times root 5 will give me minus root 5, and minus 1 times 1 is going to give me minus 1. So yeah, root 5 and root 5, they get cancelled out. again solving the whole expression, if I look at this part again, they have the same root 5 thing at the top. So what I'll do is I'll just solve the integer parts, which will give me, which is basically 3 root 5 minus 2 root 5. That is going to give me 1 root 5, or you can also write just root 5. And plus 3 minus 10 will give me minus 7, right? Whole of that over, and then you have 5 minus 1, that is going to give me 4, right? So in general, if I see, what I have here is root 5 minus 7 over 4. If you want, you can definitely rearrange that to get minus 7 plus root 5 over 4. Here you need to get the values for P and Q. So what I'll do is I'll just separate this thing, the denominator for both the terms. So I have minus 7 over 4 plus root 5 over 4, and hence the value of P is going to be minus 7 over 4, and the value for Q is going to be 1 over 4. Or you can also write root 5, but I think that will not be the correct answer because you already have root 5 over here given. So yeah, it was 1, so we have 1 over 4, and yeah, that was it. So in the next video, because this was the last topic for chapter number 1, in the next video I'll be bringing the exam style questions, which will be taken from past papers, and yeah, we'll be solving those questions with their answers in the next video. So yeah, I hope you guys actually enjoyed today's video and you found it helpful. Do consider subscribing, and yeah, till then I'll see you in the next one.